Hello guys, welcome to Bonquisitive Take. Today we are going to discuss a algorithm problem. So if you actually sit on or if you face any interviews from any big companies, you would see there's usually a separate round for data structures and algorithms. So it doesn't matter whether which language, which programming language you prefer, but usually you need to kind of be familiar with uh, I would say like proper algorithmic thinking and how you can basically solve a given problem with the most optimized solution. So this is a problem that I found in one of the interviews, and I slightly tweaked it, but this is still a very interesting problem, and we are gonna go through this. Okay, so without further ado, let's get started on with it. So I am gonna actually do it in Python first of all, and I will showcase the code in Google Colab. So you can, for anyone who doesn't know, so Google Colab is an interactive Jupyter notebook style environment for writing codes in Python. Since it's like a notebook, so you can write text or basically markdown separately, and also code blocks. You can execute those code blocks as well. So it gives you some flexibility in that sense. So we are gonna basically solve it using Python. Let's first try to understand the problem statement. So the problem statement says, let's say there's a given string and let's call it sample. Let's just refer it by sample. It consists of lowercase English characters. Now there's another integer given. Let's call it combination, though it might raise some confusion, but let's call this integer combination. And this integer basically represents the length of a target string. Now our goal, it sounds very simple. Now the goal is to determine the maximum number of times this sample string can appear as a substring in any of the possible strings of length uh, combination. Here combination means that particular integer, considering overlapping occurrences as well. So let's see whether you understand the problem statement or not. So there are two inputs here. First of all, you are given a string and then you are given an integer. Now, when you are telling that, okay, let's just assume any integer, say 7 or 8 or 9. When I assume that integer, so whatever the integer input is, you need to basically consider characters, lowercase English characters of that length. So if my combination integer is say 9, so you need to consider 9 letter strings. Now think of this like you have a proper string, you have a input string as well. Now that input string, how many times at max can appear as a substring of that target string? Okay. So now, so there were some constants as well, like say for example, the sample string, it can have a length between 1 to 2500 characters, and the combination, which is an integer, it can be an integer between 1 and 10 to the 99. So this we will discuss a bit more later. The output, it will be just an the integer representing the maximum frequency of sample appearing as a substring, including overlapping occurrences. So let's see an example, and it will become much more easier to understand once you see an example. Let's say I give the string ABBA. This is the sample string, and the combination integer is 7. So now what we need to do? So we need to understand like what is the maximum frequency where ABBA, this particular string, can be seamlessly be a substring of all the 7 character strings. So among all possible 7 character strings, the highest frequency of ABBA being a substring is 2. As you can see, the string would be like if you just uh, write ABBA and then BBA. So these are 7 string, right? ABBA is 4 and then BBA is 3. 4 plus 3 7. But now here, see this. So there's an overlap as well. So ABBA. So this is one. And then again, if you need to see ABBA, then you this the middle A will be overlap. So overlap is allowed, as you have seen. Overlap is allowed. Now there are two. The frequency, the highest frequency is 2 because you can't actually find uh, three ABBA being seamlessly integrated into a 7 character string. And these 7 character strings can be anything, right? Obviously, it would make sense if you just repeat it, but this is basically the question. You need to find out this frequency, this true frequency. Now, when you think about this problem, so this problem is given, you need to basically write a code for this, and you need to think of like all the possible scenarios, and you need to also think of an optimized solution. So, what's the easy solution? Easy solution often is like a brute force approach, which is easy to think through, but it's usually, I would say, like uh, not very intelligent, or it might actually provide you with some difficulty in terms of the space complexity or the time complexity. Like it might take a long time, or it might actually be not spatially efficient program, and also sometimes it can be computationally inefficient as well, right? So the easy solution, how you think of a brute force or easy solution? You can think of like what are the steps in the algorithms? You can think of first generate all possible combination of lowercase English characters of a given length. And what this given length is, it's the combination, right? So you are already given this string and the combination number. So you can think of generating all possible combinations of this of lowercase English characters of this length of this integer. Now, for each combination, you need to find out how many times the sample string can appear, considering overlapping occurrences, and then obviously track the maximum frequency of the sample. So you put a counter as well, and you basically add one to it whenever you find like, okay, this is the uh, highest one that you are finding, if you are finding from that. So you need to basically find the maximum frequency. This is a brute force approach, and as I have mentioned here, easy doesn't mean optimized. This is not an optimized solution, and why that is so you can easily understand. The first step where we need to generate all possible combinations, and then for each combination we have to basically iterate and see how many times the sample string can appear, and we also need to consider overlapping occurrences as well. So now if I just say combination is 7, it's not that I would say large, because if you think what's the normal way? So say for example combination is just 2, combination equals to 2. But even if combination equals to 2, now for the first letter there are 26. So there are 26 letters in English alphabet. So now, how many possible occurrences? Possible occurrences equals to, for the first letter you have 26 chances, and for the second letter you also have 26 chances, right? 26 into 26, which means like whatever the combination number is, instead of 2, let's say let it denote by n, which is an integer. If n is an integer, then it would be 26 to the power n. So now, if you remember, I said like there are a few constants, like what would be the combination integer? It can be an integer between 1 and 10 to the power 99. So it can be a very large integer. If I just say n equals to what? N equals to 10 or 20 even. Do you know how big this number can be? Just let's assume n equals to 10. Then what would be 26 to the power 10? Let's just also print it out. Possible occurrences. Just say 26 to the power 10. Oh, this is some, okay. I forgot that this is not, uh, so to the power is not referred by this symbol in Python. This is this. If I calculate this, this is coming as a very huge number. Okay, this is the issue. Now you have to basically iterate through all the whole number, and you need to basically count how many times the sample string can appear. So obviously, uh, it is not a very optimized solution. So we need to find an optimized solution. And there are multiple ways to actually solve it. We will just follow one approach, but there are other ways, other optimized ways to solve it as well. So what we would do, we would use something called uh, Knuth-Morris-Pratt algorithm. You don't need to remember the name, but basically there's a famous algorithm called Knuth-Morris-Pratt algorithm. And what does it do? The algorithm will basically use for pattern matching within a string. So it kind of pre-process the pattern to create a longest prefix suffix, which means that it tries you to understand like what can be a prefix, what is the longest proper prefix, which can also be a suffix. You know what prefix and suffix is, say for example in ABBA, and proper suffix is something slightly different. So let's assume a string ABBA. Okay, so here you can think, so if this is a string, so A is a substring, A is a substring of it, and A is also a prefix of it. Also, A can be thought of as the suffix as well. So prefix is what appears in the initial characters, and suffix is what appears in the later part of the characters, right? So A can be thought of as both prefix as well as suffix. Now, when I go to AB, AB is a prefix, but you can't find AB as a suffix as well. There is a suffix called BA, right? So this is what we are trying to find. Like for a given string, what is the longest proper prefix, which can also be a suffix. Now, what does it would do? It would actually give you the actual kind of understanding of how much characters you have to play with when you are considering overlapping. Okay, and using this information, once you have that information for any given string, now you can very easily find out how many times that particular string can be fit into the whole combination, whole combination number of strings, right? So this is what we are gonna do. So let's get into the code. Let's delete this. Okay, delete this and start a code. So how does KMP now work? So I just told you KMP is a way where we will gonna find the longest proper prefix. But how do we do it? So what we do is we let's so this is a basically KMP basically what it does is it's kind of a pre-processing step where it kind of give you an array where what does that array is. So this particular array, if you think of it, the ith position of that array, the ith position of that array is basically uh, can is equals to, like, it matches to the pattern of 0 to dot 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 I up to that point. And once we start coding, it would become much more easier to understand. Okay, so let's call it. So the first function that we are going to write is where we are going to compute the LPS, or longest proper suffix. Compute LPS pattern. So whenever it takes a pattern, first of all, what we need to do, let's create a just an initiate an array. Okay, so let us initiate an array with the array dimension. What would be the array dimension? The array dimension should be similar to the length of the pattern. So how we can do this? So just initiate it with 0 into the length of the pattern. Okay, so this is so we initiated one array, and let's also for starting out, let's also call length equals to 0. What is length here? Let's also write some comments so that we understand later on. So length, let's try to make it slightly separate. Length of the previous longest prefix suffix. Okay, I think prefix and suffix are one if anyway. The spelling doesn't matter. So there's one counter, and then let's have another counter index for the pattern. Yeah, uh, not index for the, yeah, but so basically we need to understand which character we are at, right? So character pointer. Okay, now we are gonna write a loop. So we need to basically iterate over all these patterns, right? So It's also generating for me. So while I less than length of pattern. So while is a loop. So until and unless this is true, this is gonna happen, right? While I is less than length of pattern. So I will go from 1, 2, 3 and up until the length of the pattern. If pattern I, and it's actually generating for me pattern I equals to pattern length, what we would do when the characters match, we increment length and we set it as LPS I. Okay, so because LPS, as I said, so LP is the array. The ith position of the array should actually contain the complete uh, pattern of at that ith position. So if pattern I equals to pattern of length, then length, let's increment length. Yeah, length plus equals to 1. LPS I equals to length, and we also add I plus I one step. Now, what can else be happen? Else, so there could be two other things. One is if length is 0 or if length is not 0, right? So if length is not 0, again it's kind of auto generating for me here. So if length is not equals to 0, we need to use the previously computed LPS values only. Okay, we will use the previously computed LPS value. So that's why we are we are basically going on down. We will use the previously computed LPS value. And if length is 0, so the LPS I is also 0. So no proper prefix suffix is basically found. So we kind of set LPS I equals to 0 and just move on, right? So this is the array that we are going to find. Now, this LPS array, this helps us determine how much of the pattern we can reuse in overlapping occurrences, right? So so this was defined compute LPS. Let's see, no error comes up. Okay, great. Now, yeah. So as I said, so LPS array helps us to determine how much of the pattern we can reuse for all the occurrences where some overlapping is happening, right? So now, where can we find the longest proper prefix, which is also a suffix? We found it as the last one. So LPS minus one. If we see the LPS array, if you go to the LPS minus one, this actually gives us the length of the longest proper prefix, which is also a suffix. Okay. So let's now define. So now we have all the information that is required. So now what we can do is actually calculate the frequency. So max frequency, and there are two inputs, sample and combination. You can write something else as well. So that's not an issue. Like you can also write sample is a string, something like that. Okay. Now, first of all, we need to calculate the length of this sample string. So let's say length of sample string is just we can use the len function, length of sample. And now with this length, we can also find out the LPS as well. So LPS equals to, we can use this function that we have written initially. So compute LPS of sample. Okay. So we will get the LPS array for the given sample. Now, how do we find the overlap? As I said, the overlap would be just length of the longest proper suffix, which is also a suffix. It is basically found at the last position, right? So overlap equals to in the LPS array, and if you just go to the -1. So this is also a way of getting the last uh, position object. Okay. Now there's one thing that can happen. So say for example, we also need to basically make sure that all the edge cases are covered as well. So one edge case that we can think of that is not covered yet is if the length of the string is greater than the combination. So let's say in the previous example, if you see like say ABBA, here the length of the string is 4 and the combination is 7, right? But say for example, this is 4 and the combination integer is 2. Obviously now the whole problem statement doesn't make sense, and it should the maximum frequency should come as 0 because now you can't fit this sample string inside combination strings. So what we can do is just put one test case, like one scenario, like if length of S is less than combination, return 0. Okay, if sample is basically longer than combination, we can't obviously fit it. So maximum frequency should come as 0. Uh, Otherwise, so you can write else or otherwise the maximum occurrence. So this is just one scenario. We do not have to basically provide both if and else condition here. So let's say the max frequency or max occurrence, let's call max frequency itself equals to, now once you know like the maximum number of times sample can fit in the combination layer, right? You know how much leeway you have with all the overlaps. So what it would be now, it would be 1 plus combination minus length of S, not combination minus length of S percent overlap. It's not overlap, it's length is minus overlap. Yep, length is minus overlap. And there are two return frequencies. Okay, okay. So this is integer division. Okay, so this is done when we want to do integer division. So this is more or less looks fine. And yeah, let's run it, and we successfully run it. So now let's actually try to calculate it. Let's say max. So let's start with very easy example. So max frequency of ABBA 7, which we have already seen, right? So the string is ABBA, the sample string is ABBA, and if we say 7. Oh, okay. Did you find where I did the problem? So this is some. So this is also a part of debugging, right? Because it is not the answer that we are getting. So now when you start doing so, one thing is very clear. The max frequency, it should always be at least 1, right? If the length of it is not uh, greater than the combination number, it should always come as 1, because if it even if it is coming as 0, we are doing 1 plus this, right? And this is an integer division. So then if it is coming as 0, means it went to there. And here I noticed like instead of greater than, I wrote less than. So this is where we made a mistake. So, and this is a good way of for you guys as well. So you can obviously make some mistakes in the code, and most of your time as a developer will be spent on debugging the code. And when you debug, this is tracking the error is very crucial. You need to understand where it can go wrong and track it. Here it was a simple function, so it was we could actually do it very easily. But obviously, if you can't find them, then you can try to log or print statements at different places to understand up to which point the solution was correct and from which point it got wrong. So you need to basically trace the bug. Okay, now we have changed this, so let's run it again, this function. And now if we calculate max frequency, it's coming as 2. It is giving us the right answer. Okay, so now we can try it for some other example as well. Max frequency, but say let's try to give a bigger thing. Let's say A, B, X, C, D, E, X, C, D, E. There's some overlap. Is overlap is possible? No, because it's completely like A, B. Let's say something like this. A, B, X. There's some overlap possible. Now, how many characters that we have given? 3, 3, 6, 3, 9, 3, 12, around 12, right? So let's give a greater number. So 20. Now, if you remember, if we have used brute force, this would have taken like all eternity to go through all the 20 character strings, right? But let's see how much time it uh, take. And also let's do one thing. Let's also tag a time it function, time it magic function, so that we also understand how much time it's taking using this method. Okay. So as you can see, it's running for 20. It started running now, and it took just 2.94 microseconds. So you might think like, okay, it was running for some time, but then why it's 2.94? Because in Colab actually, it's you are using a Google Compute Engine, right? So this is why sometimes you might not get some connection. So that's why actually to understand how much time is required by the processor to process this or execute this, you should do some timing. Because as you see, there's a variation of when it's going full circle versus when there are dotted circle, dotted dash, which were circling, right? Anyway, so it just took 2.94 microseconds. So this is very, very less time. And oh, we also missed the max frequency of this thing. Anyway, this is bad. Uh, yeah, it just showcases us this. So what we should have done is also print this, since there are multiple thing. Anyway, uh, only once. Do you know why? Because if you see the number of characters it has, A, B, X, C, D, E, X, 7, C, D, 9, 3, 12. So obviously these are 12 characters, and there are not enough overlaps that you can do. But if I do, say for example, instead of 20, if I do say 25, now something different will happen. Yeah. Now you can do 2. If I say 39, say for example, now you can do 4. So you understand how this thing is doing. So uh, you can actually work with palindromes. The palindromes are, I would say, uh, a great thing to try out. And say 9. And if I say AA, it's 1. Anyway, you guys can try various stuff. So hopefully you have understood how to solve this and how not to think about the brute force approach, but also try to understand an optimized way of doing something. This algorithm, so you can go and read about KMT algorithm in much more detail so that you can actually follow along. But basically try to understand this. So the execution part will come after you understand how the algorithm works. And here what we are trying to understand, here we're trying to understand first of all what's the length of this string. And obviously 9 is basically the target string, right? The target sequences should have 9 letter characters. Now if I have, say, at this time, this A B C B A, it has 6 characters. Obviously there are 3 more characters that I can arrange here. So obviously the first one, I would try to fit it this string itself. Now there are three more left, right? Now, how would you can make it two? This maximum frequency, you can make it two if some of the suffix also comes into the prefix, right? If some of the suffixes come as prefix as well, then there would be a larger overlap. The larger the overlap is, the more number of times you can basically fit this string as a substring. So this is what we need to understand, and this is how KMP algorithm works. Now the actual execution of it, uh, just basically look at this code. You can also read up more on KMP algorithms, and one of the things is basically the time complexity of it is very small. It's like order of n. So the time complexity is very less in terms of if we compare with the brute force approach. So this is how you should approach any kind of algorithm problems. You think about, and you need to also read about different algorithms as well and how they work to have a much more, I would say, diverse expertise on this. So hopefully you learned something new today, and let me know if you have any questions in the comments. And follow Bonquisitive Tech for more code related, more tech related videos, take awesome videos. Thank you guys. Have a great day.